In a previous lecture, we looked at all the different uses of const. In this lecture, we're going to take a look at several different uses of static. We've previously talked about using static with a local variable so that the function containing that local variable is able to retain a memory of what happened the last time the function was called. As a reminder, here on slide 2, we have this not very random number generator, nvrand. When we call nvrand, seed is allocated on the stack as a local temporary variable initialized with 2. Then we do a computation involving some prime numbers and return the new calculated value of seed. Unfortunately, as soon as the function returns, seed is deallocated from the stack, and so the next time we call this same nvrand function, seed is going to get recreated, initialized with 2, and we'll end up getting the same random number back over and over again. So our solution to this problem is shown on slide 3. We prefixed static in front of the declaration of seed. Now seed is allocated in the static data area, and it exists whether we're currently executing this random number function or not. When we call rrbrand, the really bad random number generator, the first time, that is when seed in the static data area is initialized with 2, and later when we call this function again, that initialization part is ignored, and we simply have the value of seed as it had been computed the previous time this function was called. So the first time we call the function, seed is initialized with 2. Seed is recomputed involving these prime numbers in a linear congruential algorithm, and we return the updated value of seed. The next time we call this function, seed will contain whatever that previous updated value was, and we recompute seed and return a different random number. Now, we describe this as a bad random number generator because a linear congruential algorithm is cyclical, and if the random number that you get back is, let's say, 17, then you know exactly what the next random number is that you're going to get back from the formula used to compute the seed. For many applications, this is random enough, but it's not really very good. We also talked about global variables. A global variable is a variable defined outside of any function and is visible throughout the entire program, except for nested blocks of code, such as functions with parameters that have the same name as the global variable, or that have a local variable that's the same as the global variable. In those nested situations, the global variable will be hidden from view. You can only define a global variable one time. You can declare the global variable as many times as you wish using the keyword extern. And in fact, if you need to share access to a global variable between files, you must use the extern keyword in any file that's going to want to have access to that global variable. Here on slide 5, we've declared I as an int initialized with 42. I is a global variable here because it's defined outside of any function. And in order for I to be accessible in some other source code file, here we have file a.cpp on the left side, in that other file we have to use the declaration extern int I. The extern declaration tells the compiler, "Dear compiler, I promise that there is this global variable containing an int called I, but I'm not defining it here. It must be defined somewhere else. All right, so we have one and only one definition, which in this case happens to be in file b.cpp. We're permitted to have as many extern declarations as we wish, anywhere that we wish. So in file a.cpp, we're saying extern int I above main. We're also saying extern int I within main. That's fine. That's just declaring the same global variable as extern. And even in the file where we defined I as a global int, we're saying extern int I, and this is also fine. So you can have, thousands of extern int i's strewn around through your source code files, as long as you have exactly one int I definition in exactly one of the files involved in your program. The linker is responsible for making sure that the global variable I defined in one file is tied to all of the uses of I where I was declared extern in other files in your program. Now, where static comes into this conversation about global variables is if you have a quote global unquote variable declared static, that is, if you have a variable defined outside of any function, but you put the static keyword in front of that definition, then all of the code in that same source code file will have access to that variable, but other code in other files will not. Now, strstrip refers to these as file local variables. I like to refer to these things as module variables, thinking that in some sense a source code file is a module. And the idea here is that you have a variable that just needs to be shared among a certain set of functions, but not any other functions. So you can define all of those other functions and the static global variable that they need to share in one file to get yourself a file local or module variable that these functions can share. And here on slide 7 we have a brief example. Notice in file 2.cpp we have an int I variable initialized with 42. This thing is declared static, which means that all of the functions in this file 2.cpp file have access to that int variable I, but other files outside of file 2.cpp cannot access that int variable I. Over here in file 1.cpp, where our main function is written, I could say extern int I, but that would turn out to be an error when the linker tried to gain access to this supposed global variable I. All right, because in file 2, the variable I is global, but only within this file itself. The name I is hidden from other outside files. All right, so return I has access to I. Mult I by 2 has access to I within file 2.cpp, but any code in any other files cannot gain access to this file local variable or module variable called I. All right, so those are the two uses of static that we have discussed before. That is, you can have a static local variable within a function so that that function can maintain some memory of what happened with that variable the last time the function was called. And you can have a static quote-unquote global variable in a file so that only the functions in that file can share access to that variable. And code in other files cannot gain access to that variable, even if they try by using extern.